Hope everyone's doing all right. It just seems like every day more and more things are getting shut down, so make sure you guys have what you need. Okay, close this. So, conditional probability, when watched and explained, might seem a little crazy or complex, but in reality, it's really straightforward and there's not really too much to it. So I'm going to try to dumb it down a little bit so that you guys can just kind of see where everything's coming from, or just how to set it up and get your answer here. So if I was going to show you just a general, say you wanted a probability of A given B. So what we learned here is probability is going to be written as a fraction, right? This you're given, that's always going to be your denominator. Okay, so the probability of B, that's always going to be your total. That sample space is what's going to be on the bottom. Yeah, Chris, we do, but Chris, we're going to be doing Algebra 1 in an hour. So this is the trig lesson. So if you come back in an hour, we're going to do that, and I'm going to explain what you need to do. Okay, so, and then what you're going to do on top is the probability of A and B, or your intersection. And that's it. That's all you want to have down. That's all you want to have down for conditional probability. There's nothing else to it except for this, or for what we want to know. So if I look at exercise 2 here in the notes, not the homework yet, in a school of 1,200 students, 250 are seniors, 150 take chemistry, and 40 are seniors, senior who are also taking chemistry. What is the probability that a randomly chosen student is taking chemistry given that they are a senior? So if I was going to write that, it's going to be probability that a student is taking chemistry. Good morning, Tiffany. Afternoon, a little close. Given that they are a senior. So if we look at that formula, all you have to do is tell me how many are chemistry students and they are seniors, divided by, now this is always our denominator, how many of the seniors we have, okay? So chemistry and seniors, 40 are seniors who are also taking chemistry, that's going there. And then how many of them are seniors, that's 250. So then we're going to do 40 over 250. And I don't have any of my notes here. That's okay. I have a calculator. 40 over 250 and 0.16. And there you go. And you can multiply by 100, get 16%. But that's all you want to know or can keep in mind when you're doing conditional probability. Okay? So that was, and the rest were went over in the video. But let's take a look at the homework and see if I can keep going through this to see if you guys are pretty good with it. And again, ask as many questions as you need in the next little while. Okay? So here it is, given that probability of B given A, okay? Then how can you convert that into like a formula? Well, that's you take those guys and just basically change the line to an intersection. So it would be B given A, or B intersection A, divided by A, because that's our denominator right there. And there it is, 4. Okay, so that's how you're going to get through that one. Okay, so that's number 1. Here's 2. Now I definitely need to go get my notes because it'll take forever for me to go through this. So take 2 seconds. I'm going to run downstairs, get my notes, and then you guys see if you can set up your probability and see if you can get the answer. And I'm back. Okay. So, of the 650 juniors at Arlington High School, 468 are enrolled in Algebra 2, 292 are enrolled in Physics, and 180 are taking both courses at the same time. If one of the 650 juniors was picked at random, what is the probability they are taking Physics if we know they are in Algebra 2? So probability, they're going to be taking Physics, and we know that they're in Algebra 2. Well, take all of our students that are in Algebra 2, 468 are enrolled in Algebra 2. Then figure out how many of them are in Physics and Algebra 2. 180 are taking both courses at the same time. So that's 180 over 468, 0.38, choice 1. Okay, then we go down here, number 3. So we read this, they want to know probability of rain given that it's going to be snowing. So figure out rain and snow, that's going to go on the top. And then just the probability of snow is going to go on the bottom. So if we read this, 18% chance of snow, 0.18. Okay, probability 4% chance it will rain and snow on that day. So that's going to be 0.04. And just remember, I'm just converting the percent into a decimal by dividing it by 100. That's where I get the 0.04 from. That's where I get the 0.18 from. And then right there, you're going to get 0.22. Okay, B. So they look almost exactly the same, but this is rain given that we know it's going to be snowing. This is what's the probability it's going to snow given I already know it's raining. Now, the number on top is going to stay the same, 0.04, because that's your intersection. But your denominator is what's changing because that's what we know. We know the rain. And then where does it say? The chance of rain was 12%, so that's 0.12. And then 0.04 over the 0.12 is going to be 0.33. Okay, so again, ask questions. Let me know how you're doing with this. Okay, so a spinner is spun around in a circle is divided into 8 equal sections. Perfect square and even, okay, given that it's even. So if I look at here, 2, 4, 6, 8, that's the number on the bottom. 2, 4, 6, 8, that's my even. And now, how many of them of those 2, 4, 6, 8s are also perfect squares? 4 is a perfect square, so I only see one of them, okay, because my evens again are 2, 4, 6, and 8. Your perfect squares on here are 1, 4. So what do they have in common? That's the 4, so there's only one of them. So you'd say 0.25. Okay, odd and prime. Okay, now if you're not sure, prime is a number that can only be divided into itself and 1. So 1 doesn't count. The only numbers that divide into 2 are 2 divided by 2 and 2 divided by 1. He's prime. 3 divided by 3, 3 divided by 1. That makes him prime. 4, you can do 4 divided by 1. You can do 4 divided by 4, but you can also do 4 divided by 2. That's why he's not going to be prime. 5 and 7. Okay, don't just say they're odd numbers because that's not true because we have 2 in there. So we have 4 prime numbers. Now, of the ones that we just marked, which one of them are odds? Well, 3, 5, and 7. So that's 3/4, and that's 0.75. Thanks, Sandra. Everybody does something different. I'm pretty good with doing some of this live and YouTube, and Miss Holden and I already had a lot of this set up from our cimath.com. So her and we've been working together a lot to get through this. So it's I might be in the front, but there are plenty of people behind the scenes also helping out, making sure that we can get all this up and live for you guys. Okay, so what is more likely, getting a multiple of 4 given we spun an even, or getting an odd given we spun a number greater than 2? Support your answer. So this is kind of looking at 2 different ones. So I don't even even know where I think. What is more likely? Getting a multiple of 4. Okay, so let's write that out. Okay, multiple of 4. So who is our multiples of 4? 4 and 8, right? So that's 4 and 8. Given we spun an even. Okay, given we spun an even, so our evens we said 2, 4, 6, and 8, right? So 1, 2, 3, 4. That's going to be our denominator. Now what's in common between here? 4, 8, 4, 8. That's 2 numbers. So you have a 1 and 2 chance there. Or getting an odd. So it's odd. Who are my odd numbers? 1, 3, 5, 7. Given we spun a number greater than 2. Who's greater than 2? 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6. So there's 6 here. Now, what's the intersection? What do they have in common? They have a 3 in common. They have a 5 in common. They have a 7 in common. So 3 over 6. So 1/2. So they actually have this same probability. So both of them are the same. One is not more likely than the other. Okay. Now let's go from reading a table, which actually is a little bit easier. In this last question, I had to figure out the numbers that would be the intersection. I had to figure out which numbers were even. But when you have a table, I'm giving you all the numbers. You just have to be able to read it. So if we read the question, and then here's what they want to know. The probability of taking the train given that you're in LA. Okay, probably taking the train given that you're in LA. So if you, again, intersection of this guy, it's going to be your top number, and LA is going to be your denominator. So here's LA. My total was 0.35. Okay, so now watch how I'm going to get the intersection. I'll draw a line through Los Angeles, and then I'm going to draw a line through the train. Right there. That's my intersection, 0.12. So you're going to have 0.12 over 0.35. That's 0.34. Okay. Okay, next one. All right. What is the probability that a person picked at random would live in New York given that they drive a car? So same thing. Car, that's my total. That's going to be my denominator. That's 0.31. Now, New York City in car. So again, if I do that same thing where I kind of draw a line through New York City, draw a line through the car, try and see what their intersection is, and that's at 0.05. So now you're going to divide the 0.05 into 0.31. That's 0.16. Okay? And see what is more likely to occur, that a person who takes a train to work lives in Chicago. So let's, again, person takes a train, lives in Chicago. So if I'm going to write that out, I'm going to train given that they work in Chicago, or that a person who lives in Chicago, okay, so now, and they're going to take the train to work, okay? So we know they're taking the train. Well, are they going to be living in Chicago? Here I already know they live in Chicago. So if we do the same thing again, that's my denominator. This is your intersection. So train, so watch how they're going to go a little bit different. So first I'll look at the car. That's 0.31. That's going to be my denominator here. Then I go over to train. Wait, no, not car. That's Chicago. Silly. That's Chicago. So we got to go over here. Chicago. Chicago is 0.25. And they're going to take the train. That's better. And their intersection is 0.14. So what we have is 0.14 over 0.25. That's going to be 0.56. Or you could say 56%. Now let's do the other one. So here's my denominator. That's the train. So let's go here. So now my denominator is going to change now to 0.51. And now let's find the intersection of living in Chicago and taking the train, which is 0.14. So 0.14 over 0.51, that's 0.27. So you have a better chance of taking the train and living in Chicago than you do living in Chicago and taking the train. Okay, and 6. Okay, they want you to basically prove this. Don't get too caught up on this. If you get kind of lost on this, it is what it is. We're more concerned about you being able to answer the questions from a table or that spinner question. But here they're just asking you to solve it. So kind of think back to this as like a 9th grade question. I could put this over 1 and then just cross multiply. Okay, but just not thinking too much. So 1 times the probability of A and B is probability of A and B. And then here says probability of B given A times the probability of A. Probability of B given A times the probability of A. And it says solve this formula for P and A. Okay, so they're basically asking you to get this guy by himself, which we did, and right here, here's your answer. Okay, so take it for what it's worth. And 7, I'm just going to spare you all of the confusion and just say, don't worry about it. If you really want to read it, then and read it and try it, and you can play it back. The answer that you could write would be, given A has occurred, it will not change the probability that B will happen. Probability of B given A is just the probability of B. What that means in English, okay, they're saying you have 2 events, A and B, and they're independent. So just think about what it means to be independent. And think about probability. So if you're independent, then one is not affecting the other. So the probability of B given A is the probability of B. The probability of A given B is the probability of A. A doesn't affect what's going to happen to B and vice versa. Okay, that's what it means to be independent. Okay, so that concludes our video for today. What we are going to try and have you do is we are going to be putting a quiz up for you or some work for you to do online. So it's good practice stuff. So go to www.cimath.com and we're going to start leaving some things that we can just kind of check to see what it is that you are and aren't getting and seeing how effective the videos are. So as always, if you have any questions or comments, you can leave those down below. Let your friends know that are in other classes that may or may not be having some work to do. Hit the subscribe button, like button, let me know what you guys think.